So now in the chapter relations and functions, so second type is types of functions. Already in the last class I explained to you types of relations, and now that exercise also I explained. It is exercise number 1.1. all the problems I explained. Now it is about types of functions. So this concept is already studied in class 11. It means last year you studied. So which are the types of functions you studied? So it's identity function you studied, constant functions, polynomial functions, rational functions, modulus functions, signum functions, and these all are the types of functions you studied, right? So now we have to study the few more functions in the diagrammatic ways. So here it is there. x1 is the one of the term, and x2 is the one of the set. Here the function I am considering it is as f1. Now here it is what x1 is the set 1 2 3 4, and x2 is same a b c d e f. Okay, now f3 is the third function, 1 2 3 4 is the same, and a b c are the x3, and f4 is the one of the function, a fourth function, 1 2 3 4 is the first set, and a b c d are the second. Is what x4 we have to consider it. So we have the three types of set here. It means types of functions. One is 1 function. Okay, so 1 function. 1 function is also called as what? Injective. What is meant by the other one? It's what? Injective. 1 function are also called as it is what? Injective. And next one is onto function. Onto function, or it's also called as what? Surjective. What is it? Surjective. And then one more third one is bijective. So bijective is the name itself. It is a bijective means both 1 and onto. 1 and onto. So if it is satisfying both 1 and onto, that's what? Bijective. So in the last in the relation we know that it is a reflexive, symmetric, and transitive means we are consider it as the equivalence relation, no? So like that here it is satisfying 1 and onto, that is called as what? Bijective. Here in this function f1, f2, f3 and f4, which is 1 function and which is onto function? Before that we came to know it is what? Domain, range and codomain here. These are the, what is this we can write now? These all are what? It is a domain. Here it is domain is 1 2 3 4. Then codomain is what are the elements are there in the x2, x3 and x4? a b c d e f, a b c d e f. This is what? Codomain, all the terms. Then one more word is that it's a range. Range means the function satisfying with the elements. Here 1a, 2b and 3 to e and 4 to d. Okay, a, b, d, e are the image of the x1. Okay, here a, b, d are the image of the x1, and here a, b, c are the image of this all the elements here. So this is what? Domain. The remaining what are the images is satisfying with the x1, it is what? Range. And all the elements we are considering in the x2, no, that is what? Codomain. Okay, now here f1 is the function. You see 1 is related with a, 2 is related with b, 3 is related with e and 4 is related with d. 1 is related with a, 2 is b and 3 is also related with b and 4 is related with d. Here 1a, 2b, 3b, 4c. 1a, 2b, 3d and 4c. Okay, so here this function is called as what? 1 function. Why it is 1 function? So one element is related with the one element. In the set 1 is related with one set 2. Here 1 is related with a, 2. So all the elements are at set 1 function. Now this also you can say it is what? 1 to a, 2 to b, 3 to d and 4 to c. This is what? 1 function. But this is not a 1 function. Here you can see 1 is related with a, 2 and 3 both are related with b. Okay, so b is the image of both 2 and 3. Here B is the image of both 2 and 3. So these two are not a, what is that, 1 function. These are what, 1 2 function. Here it is, these two are really clearly we can say it is what, 1 function. It is what, 1 function, and these two are many one function we can say. These two are what, many one function also we can say. But in the 1 2 function, it's onto function means here f1 is not a onto function. Why? Here C and F are remaining here. There is no element, there is no image in this. Okay, image is not there. But here also same thing. C, E and F, there is no image. Okay, so F1 and F2 are not a onto function. But here it is there no. F3, all the elements are there. A is the image of 1, B is the image of 2 and 3, and C is the image of 4. Is there any elements are remaining here? No. Therefore, this is what, onto function. And this also same thing. 1 is related with A, 2 is related with B, 3 is related with D, and 4 is related with C. Is there any element is remaining here? No, there is no element. So this also what, onto function. This is what, onto function, and we can call it as this is 1 and onto function. But we cannot say this is 1 function. This is onto function, and these two are not a onto function. But this one we can say it is what, 1 function, and this one we can say it is a many one function. F2 is not 1 and not onto. Okay, so now this one F4 is satisfying all the both 1 and onto function. Therefore this is what, bijective. This is what, bijective. And this is not a onto function. This is only the 1 function. And this is not a 1 function. This is only onto function. I hope that is clear for you. Image, there is no element here. Here C and F are remaining. So that is not a onto function. Here C, E, F are remaining. Therefore this is not a onto function. Here A, B, C, all the elements images are there here. Therefore this is a onto function, but it is not a 1 function. Why? This 2 and 3 is both are related with B. So now we can write the definition of 1 function. So here, what is this? 1 function. So 1 function means a function f from x to y is defined to be 1 or also called as what, it's injective, if the image, what is that, if the images of distinct elements, what is this, distinct elements of x under the function f are distinct. So now the definition, if you want to write the definition for 1 function, a function f from x to y is defined to be 1 if the images of distinct elements of x under the function f are distinct. It means, so 1a, 2b, 3e and 4d, so all are distinct. Therefore it is what, 1. Here it is 1a, 2b and 3b. 2 and 3, the image is what, same, b. Okay, so therefore this is not a 1 function. It means, so for every elements x1, x2 and x3 belongs to x, the function f of x1 is equals to f of x2 is satisfying. It means it implies x1 equals to x2. Okay, if x1 equals to x2. Otherwise that function is called as what, many one. I said to many one also. So this is what, many one, and this also what, many one. This is what, 1 function. Okay, this also what, 1 function. So if x1 equals to x2, otherwise it is what, many one we can call it as. Now next it is what, onto function. if you want to write that onto function definition, everything is same. A function f from x to y is said to be onto function, or also called as it's a surjective, if every element, what is that? Every element of y, is the image of, every element of y is the image of some element of x, some element of x under the function f. That is for every is y belongs to capital letter Y. Y is one of the sets. Here it is what? No, A. A is belongs to this one and B is belongs to these two. Okay, so there exists an element x in x such that, so for this we can write it is what? F of x equals to y. F of x equals to y. Okay, clear? So this is what? Onto function. Now here we want to say that bijective function, so both are satisfied. A function, it is what? Bijective. It is what? Bijective function. So what is meant by bijective function? A function f from x to y is said to be 1 1 and onto. If f is both 1 1 and onto, that is what? Bijective. Function is both 1 1 and onto, it is what? Bijective. Here this f4 is our bijective function. Clear? So I hope that all of you clear now. So now we can consider the one of the example now. Show that f from n to n, the function f from n to n is given by, I will explain this example now, is given by f of x equals to 2x. We have to check whether it is 1 1 or onto. Okay, so f of x equals to 2x. So first is what? 1 1. We have to check whether it is 1 1 or not. The function, it says that 1 1 function definition, it says that f of x1 equals to f of x2. It means f of x1 equals to f of x2, right? So here it is f of x1 means 2x1 equals to 2x2. So f of x is 2x, no? F of x is 2x. That's why f of x1 we can write it as 2x1. And this equals to 2x2. So now 2 get cancelled. x1 equals to x2. So f1 equals to x2 means it is what? 1 1 or not? Yes, therefore it is 1 1 function. It is what? 1 1 function. Okay, but onto function we have to check now. We have to check whether it is onto or not. So 1 is belongs to n. 1 is belongs to n. Okay, there does not exist any x in the natural number such that, so f of 1 is belongs to n and f of 1 equals to what? It is 2 into x it is 2x. No, this equals to what is that? 2 we are getting. 2. But the image is what is that? This side, it is not that. So it is not onto. It means there does not exist any x in n. Does not exist any x in n. So here it is what? N belongs to 1 belongs to n. And this is what? 2 of 1, it is 2x. X means what? 1, it is what? We are getting it as 2. But it is equals to 1? No, it is not equals to 1. So therefore this is not a onto. It is not a onto. Therefore this f of x equals to 2x is only 1 1 but not onto. Okay, so not onto. So clear? Now the function f from R to R, function f from R to R, this is what? Natural number to natural number. This is for function f from R to R. So you have to check whether it is a 1 1 or onto. Okay, now f of x1 equals to f of x2, it is what? Same. Then our function, it is a function is f of x equals to 2x, only the function. This is a function, no? So now 2x1 equals to 2x2, it is x1 equals to x2. Therefore it is what? 1 1 function. Therefore it is what? 1 1 function. Now we have to check whether it is a what is it, onto or not. Okay, so the real number is r exists, real number r is exists. What is that? You can consider this term, it is y divided by 2. Y divided by 2, it means 2x equals to y. So x equals to what? Y divided by 2. You can take 2x equals to y. This function you consider it as y. So x equals to what? Y divided by 2. So now y divided by 2 in r or not, such that f of y divided by 2 equals to 2 into y divided by 2. This is what? Y. 2 and 2 get cancelled. So this function is there or not. Therefore f is onto. F is onto. But if you want to consider here 2x equals to y, then x equals to y by 2. Y by 2, it is not belongs to n. It does not belong to n. Y by 2 is possible? No, it is not possible to comes in the y divided by 2 form. Okay. Otherwise here is a function. If you want to take this, what is that? F of y2, f of y by 2 equals to 2 into y by 2. Then 2 get cancelled, equals to what? Y. Equals to what? Y. Y is not there. F of y divided by 2. It is not there. Okay. So that is the way you have to understand it. Now I will explain that exercise problems now. Exercise number 1.2. Exercise number 1.2. Let us see the first question. Show that the function f from r star to r star defined by the f of x equals to, so first one I am explaining, f of x equals to 1 divided by x is 1 1 and onto, where star r is a set of all the non-zero real numbers. This r is what? Non-zero real numbers. Non-zero real number. Okay, so this is what? Non-zero real number. Is the result true if the domain R is replaced by n with the codomain being same as R? We have to check. Okay, so now given the function is f of x equals to 1 divided by x, we have to consider it 1 divided by x. Now we have to check with the 1 1 function. How to check the 1 1 function now? So 1 1 function is let x1 and x2 is belongs to R. 1 and x2 is belongs to R. Okay. So now f of x1 is equals to f of x2. F of x1 is equals to f of x2. So f of x is 1 divided by x. So 1 divided by x1 equals to 1 divided by x2. This implies what? x1 equals to x2. Therefore f is 1 1 function. Therefore f is 1 1. So now we have to check whether it is onto or not. This is what 1 1 function is for. Now we have to check whether it is onto. F of x. F of x equals to 1 divided by x. F of x equals to 1 divided by x means range of f is equals to r naught equals to codomain of f. So codomain of f. Therefore f is onto. So range of f is equals to r naught, all the positive values. No, so codomain of f. Here we have to consider it is what? F of x equals to y, then 1 by x equals to y. So y equals to 1 by x. It is what? Same. X equals to y we are getting. So therefore f is function f is 1 1. Sorry, onto and 1 1, or 1 1 and onto. Okay, clear? So this is what? 1 1 and onto. Both are satisfying. So now next continue part of that question is, here it is, question is given. What is it given? Is it true if the domain of R is replaced by n with the codomain being the same as R? So you have to check. How to check this? So if the domain R is replaced by n, if the domain R is replaced by n means the function f from n to R, then the function, so what is that? Then the function, what will be the function now? Function will remain, okay, so function will remain 1 1, so only 1 1, however not onto. So why it is not onto? You know that already in the first case we discussed it. In the real numbers it is both 1 1 and onto. The previous one we discussed, here it is what? Only that 1 1 function. This is not a onto. It means in the natural numbers it should not be a onto function. Okay, so here it's replaced by 1 1 onto. Therefore what is the range we can write? Therefore range, here I am writing. So therefore range, so range of f, it should be, what is that? 1, 1 by 2, 1 by 3 and so on. It is not equals to R naught. It's not equals to R naught. Why it is not equals to R naught? It's not a onto function. It's only that 1 1 function. So clear? This is the first problem solution. So now the second one is check the injectivity and surjectivity of the function. Check the injectivity and surjectivity of the function. So first question in that, f from n to n given by f of x equals to x square. F of x equals to x square. So now we have to check. So answer, how can you write the answer for this? x1 and x2 is belongs to n. It's a natural number. Therefore f of x1 equals to f of x2. X square, no? x1 square equals to x2 square. x2 square. So now x1 equals to plus or minus x2. x1 equals to plus or minus x2. So here we have both the two results. One is x1 equals to x2 and another one is x1 equals to minus x2. Therefore it is an injective or surjective. x1 is belongs to n. It is surjective or injective. Here x1 and x2 is both are belongs to n. It is there. Therefore it is injective. Okay, so therefore it is injective. So clearly we can say this is what? F is a function, f is a injective. Now we have to check whether it is a surjective or not. A range of the functions we have to check now. So here x square is there, no? X square. So for some elements like which one? 2, 3, etc. So these elements has no image. It means pre-image or pre-neo image in n. Here f of x equals to x square. If you are taking x is 1, the function is 1 square. If you are taking 2, the 2 is comes what is 4. And if you are taking 3 is what? 9. Then 3 is not there. So here 2 and 3 are 5 or 6. So like that terms are not there. So such that f of x equals to 2. F of x equals to 2. So f of x equals to 3. Hence, so therefore what is that? Hence f is not surjective. F is not surjective. So it is what? Only the injective, but it is not a surjective. Why? It is what? X square. All the terms pre-image is not there. All the terms pre-images should not be the term. Okay. Second one. Okay, function f from z to z, it's given by f of x equals to x square. F of x equals to x square. So f of x equals to x square means x1 and x2 is belongs to z. Okay, so for example, we can consider it for this. F of 1 equals to 1 and f of minus 1 is equals to also a 1. So both are 1. So 1 is equals to minus 1. It is not possible. It's not possible. It's not many one function. Therefore, it is not injective. It is not injective. Then we have to check with it onto function. So we have consider it as x square equals to y. X square equals to y, or f of x equals to 2. F of x equals to 2. Now what about the x? X equals to root 2. No. So root 2 means is belongs to z or does not belongs to z? Yes. It is not, does not belongs to z. So we will get x equals to root 2. So that is what does not belongs to x. Or we can consider it as x square equals to y, then x equals to root y. X equals to root y. X equals to root y is belongs to z or is does not belongs to z? It's what? Does not belongs to z. Therefore, it is not surjective. It is not surjective. Clear? So now third one. F from R to R such that f of x equals to x square. R to R. Now we have to check whether it is injective or not. F of x1 equals to f of x2 equals to f of x2. x1 is equals to x2 we are getting, no? So plus or minus x2 we are getting. So what is this? Therefore it is not injective. So why it is not injective? X equals to plus or minus x2. One is x1 equals to plus x2 and another one is x1 equals to minus x2. It is not possible to get. So it is not a injective. Next, what about the range here? The range of f does not contain any negative real number. Therefore, it is not surjective. So clear it is. Why it is not a surjective? Here the real number has all the positive and negative values. But here x square is only we are getting the positive value. We are not getting any negative values. If image it should be means both the positive and negative value it should be same. Okay. So 2 minus 2 the value is 4 and 2 is value is also what? 4. Okay. But 2 minus 2 and 2 there is not a pre-image. Clear? So now fourth one I'll take it. F from n to n, then function it is what? X cube now. X cube. So x cube means whether it is a 1 1 or not. Yes, it is about 1 1. How okay it is 1 1? x1 and x2 is belongs to n. We can consider it. F of x1 equals to f of x2. F of x1 cube equals to x2 cube. Okay, x1 cube equals to x2 cube means x1 equals to what? X2 only. X1 cube equals to x2 cube. It's a natural number. All are natural numbers. So x1 equals to x1. Hence, what we can say it is what? 1 1. Or it is what? Injective. Okay. Now we have to check it is a surjective. It is surjective or not. So what about the range now? Range of n is equals to what are the function you are getting? Sorry, range of f equals to what are the function you are getting? 1, 8, 27 and dash dash dash. Is it a natural? Yes, all the natural numbers are not there. It means 1, 8, 27 are there. But what about the remaining numbers? No, it is not there. Therefore, f is not surjective. F is not surjective. Clearly you think here the range of function is 1, 8, 27 and all the natural numbers are not there. Therefore, it is not a surjective. Okay, so the third case what here it is there. This is what not a injective. Not injective means x1 is has a both two values. It is not possible. And the range it is a negative value. It is negative value is not coming only. Here x square is there. but there is no negative value. Okay, so here also same thing. So x square is z. One is positive and another one is negative value. The same case we can consider it like this only. Now, but here it is root we are getting. Root term we are not getting in the which value? Z integer value. Okay, clear? So now last one I am taking now fifth one. F from z to z is given by f of x equals to x cube. F of x equals to x cube. So now you have to check x1 and x2 is belongs to z. Okay, f of x1 is equals to f of x2. Now x1 cube equals to x2 cube. It is z. So x1 cube equals to x2 cube means x1 equals to x2 we are getting. Here it is, what is that? So f is 1 1 function. Therefore, hence it is 1 1 function. So if it is what? 1 1 function. X cube is all the z. Okay, so x1 and x2 is a cube is there. Now next it is a onto function. If you want to check onto function, a range of f is equals to what is that? 0 plus or minus 1 plus or minus 8 plus or minus 27 and so on. It is does not belongs to z. Why? Only 1, 8, 27 are there. The remaining times not there. Therefore, the function f is not surjective. F is not surjective. So clear? I hope that all of you clear. Otherwise, once again you can go through all these problems. Okay. So now I am explaining the third part problem. So third problem. What is that? Prove that the greatest integer function f from R to R. So here it is as the third problem. Prove that the greatest integer function f from R to R is given by f of x equals to the greatest integer function is x is neither 1 1 or onto, where x denoted the greatest integer less than or equals to x. Okay, so now this is the problem. The function, what is the function? Function is f from R to R. Then f of x equals to greatest integer function, it is what? X. So how can you prove this? By that the greatest integer of x means for all x value is belongs to 0 and 1. Okay, so it is 0 and 1. It means the greatest integer less than or equals to x. Less than or equals to x. Okay, so now f of x equals to modulus of x is equals to what? 0. So therefore f is not 1 1. F is not 1 1 or injective. So clear? It's not 1 1 or injective. F of x equals to 0. Okay, so now for example, how we are understanding, say 0 and 1 divided by 2, it is belongs to R. Then that implies f of 0 equals to what? It is 0 only we are getting, and f of 1 divided by 2 is what? 1 divided by 2, it is equals to what? 0. 1 divided by 2. Range of f is the set. The range of f is the set of integers. Set of integers is not equals to R. Set of integers is not equals to R. Hence, f is not onto. F is not onto. So therefore it is what? Not 1 1 and not 1 2. Why? It's the greatest integer function 0 and 1. So satisfying the values, it is what? X and comma 0 we have to get. Otherwise, we can simplify this problem in the other way. How can you get that other way? Or we can get it. F of x equals to what? The greatest integer function is x. Okay, so we have to check it is an injective or not. Let x belongs to 0 and 1. So you know the difference between these columns, square bracket and common bracket. It belongs to what? R. Is a subset of R. Then f of x equals to 0. That is, f of 0 equals to f of 0.1. It is what equals to 0 only, greatest integer function. This implies 0 is not equals to 0.1. This implies 0 is not equals to 0.1. Therefore, x1 is not equals to x2. x1 is not equals to x2. Therefore, f is not injective. F is not injective. This is the other way. Surjective means range of f is equals to set of integers. Range of f is set of integers. Therefore, range of f is does not belongs to R. It means does not equals to R. Range of f is set of integers. Set of integers. So, it means is the greatest integer less than or equals to x. Greatest integer is less than or equals to x. The function is R to R. Therefore, this is not a onto and it's not a 1 function. It's not injective and it's not a surjective also. Okay. So now fourth one, I consider fourth one. So greatest integer function is over. Now it is a modulus. Show that the modulus function f from R to R such that f of x equals to modulus of x is neither 1 or nor onto, where f modulus of x is is a positive or 0, and x is, if it is a negative, x is negative. Okay, so that problem we have to simplify. Modulus of x means f of x equals to modulus of x. It's always positive values we have to consider it. Positive values. So the given function is f of x equals to modulus of x. Now f of x equals to f of minus x. Both the values now. This implies x is not equals to minus x or x equals to minus x. Yes, f of x is equals to f of minus x. Why? The both it is the value it becomes, one is plus x and another one is minus x. Modulus means one is plus x and another one is minus x. So f of x equals to f of minus x. It is equals to what? X is not equals to x1. Therefore, f is not onto. F is not 1 function. 1 function. So now we have to check whether it is injective or not. So injective is over, it's injective. Now surjective or not we have to check. So what is that? Surjective. It means the range of f equals to which and which? 0 to infinity is equals to R, no? 0 to infinity we are getting. 0 to infinity. 0 to infinity. All the infinity terms we are getting. That is range of f equals to set of non-negative real number. Set of non-negative real numbers. Why it is non-negative real numbers? It is a modulus. This what? Modulus. We are getting only that modulus. Therefore, it is range of f is not equals to R. Range of f is not equals to R. Therefore, the function is f is not onto. Okay, so it's a non-negative real part. Non-negative real part is not there. Therefore, what is it? It is not a onto. What is the conclusion we can give now? Therefore, the function is neither 1 nor onto. Neither 1 nor onto. Then one more function is there. It's a signum function. So question number fifth one. So signum function is f from R to R is given by f of x equals to 1 if x is greater than 0. F of x equals to 0 if x is equals to 0, and f of x is minus 1 if x is less than 0. Okay, so this is the what terms 1, 0 and minus 1. How can you prove this one now? Whether it is neither 1 nor onto we have to prove. So signum function, it is there. F of same thing. Now here function is f from R to R with the signum functions. F of x equals to which are the values we are getting 1, 0 and minus 1. and x is greater than 0 if x is equal to 0, if x is less than 0, right? So now f of 1 equals to 1 and equals to what? F of 2 also. So f of x1 equals to the function signum function, it is 1, x is greater than 0 and 1. So f of x, how can I write it? Is what x is belongs to, which are the elements? It is 0 to infinity we are getting, no? So x is 0 to infinity. So f of 1 equals to 1 and f of 2 is also what? 1. Therefore f of what we can write? F of x1 is equals to f of x2 is equals to f of x2, but x1 is not equals to x2. x1 is not equals to x2. Therefore the function f is not 1 1. So you know that the values 1 0 and minus 1. Here x1 is not equals to x2. So x is for 0 to infinity. So values, you know that these are the values. So then also range. What about the range now? Range of f is equals to what? 1 0 and minus 1. So range of f is 1 0 and minus 1. So therefore it is, therefore range of f, so what is that? Range of f is equals to r or not equals to r? It's not equals to r. It is not equals to r, right? So range is only 1 0 and minus 1. So all the real numbers terms are there, it is not there. Therefore it is not onto. Therefore it is not onto. Okay, clear? So what we can say now? Therefore it is neither 1 1 nor onto. So clear that the greatest integer function, modulus function and signum function. So now I will move to that question number 6th one. Question number 6. How to simplify that question number 6 we will see now. The question number 6 is, let a equals to 1 2 3, b equals to 4 5 6 7 and let f is 1 4 2 5 3 6 be a function from a to b. Show that f is 1 1. Okay, so how can I explain this? Function, it is f equals to 1 4 2 5 3 6, right? F of x equals to the values. After getting the values, we are getting 1 4 2 5 and 3 6. A is 1 2 3 and b is 4 5 6 7. Okay, so we have to check whether it is a 1 1 or f is a 1 1. Okay, now the function is given. The function is, what is that? 1 4 and 1 4 and 2 5 3 6. Okay, so here f of 1 equals to, what is that? F of 1 equals to 4. Now f of 2 equals to what? It is what? 5. So f of 3 equals to what? It is 6. So different elements of domain have different images in the codomain. Different elements of domain have different images in the codomain. Or also we can say it is, so here the clearly what we can say, 1 is equal to 4 and 2 is 5 and 3 is what? 6, right? F of 3 is what? 6. Therefore f is 1 1. So f is 1 1. So what is the reason we can give? The reason is different element of domain have different f images in the codomain. So all the different means x1 is images. So same, it's not a same. 2 times it is not repeating. 1 is belongs to 4 and 2 is belongs to 5 and 3 is belongs to 6. It is what correlation is there. Therefore it is what? 1 1 function. Next question number 7th one. In each of the following case, state whether the function is 1 1 onto or bijective. Justify your answer. So these two problems also very important problem. So first one is f from R to R is defined by f of x equals to 3 minus x. So first I will simplify the first one. First one in that f of f relation R to R, then it's denoted by f of x equals to 3 minus 4x. 3 minus 4x. So first part I will explain now. F of x equals to 3 minus 4x. Then for all x is belongs to what? R. Here it's a condition is what? R. Okay. Now let x1 and x2 is belongs to R. Therefore f of x1 is equals to f of x2. That implies, so we have to take this 3 minus 4x1 equals to 3 minus 4x2. 3 get cancel, minus get cancel, 4 get cancel, x1 equals to x2. So x1 equals to x2. If x1 equals to x2 means therefore f is 1 function. So it's both are what? Equal now. Now next let any y is belongs to R. Any one y is belongs to R. It is what? Codomain. Okay, so it is what? Codomain. Let f of x equals to y we have to consider now. Let f of x equals to y means 3 minus 4x equals to y. So f of x is 3 minus 4x equals to y. So minus 4x equals to y minus 3. Y minus 3. Now x equals to what? Y minus 3 minus divided by minus 4. So x equals to 3 minus y divided by 4 or not? 3 minus y divided by 4. So corresponding to every y is belongs to R, there exists a x is belongs to R. Okay. So now what are the values we are taking y? So we will get the x value. Here if you are taking y equals to 1, if you are taking y equals to 1, so we will get 2 divided by 4, it is what? 1 by 2. That's also there in the domain. So here it is what? Y is belongs to R. So x also we are getting. Therefore what we can say? Therefore f is onto function. Therefore f is onto. So now here it is 1 1 and onto. Therefore f is a bijective. What is that? Bijective function. Okay, clear? Bijective function. So this is what? X equals to 3 minus y divided by 4 we are getting. That is belongs to R. Okay, I missed this. This is what? Belongs to R. Okay, so therefore f is onto. I hope that is clear. Now second part I will explain now. F from R to R is defined by the function f of x equals to 1 plus x square. 1 plus x square. So same way we can explain for this also. Let f of x equals to 1 plus x square. F of x equals to 1 plus x square is the term. Now here f of 1, what we can say? F of 1 we can consider it as 1 plus 1 equals to what? 2, and f of minus 1 we can consider it as 1 plus 1 equals to 2. So 1 is not equals to minus 1. 1 is not equals to minus 1. It means therefore f of 1 equals to f of 2. No. So both the values are same we got. Sorry, minus 1. Plus 1 and minus 1. So 1 is not equals to minus 1. This implies x1 is not equals to x2. Therefore f is not 1 1. F is not 1 1. Okay, clear? So now range. So range of f. Okay, now tell me what is the range of f now. So range of f is relation, it belongs to R, it is 1 comma infinity. Is 1 to infinity, we can consider it f. Okay, so it is does not equals to R. It does not equals to R. Why it does not equals to R? It means range of f contains only those real numbers is greater than the 1. Greater than the 1. Why? It is f of x equals to 1 plus x square. Why it is like this? It is what? F of x equals to 1 plus x square. 1 plus x square means if you are taking it is 0, its value is 1. If you are taking 1, its value is 0. It is more than 1. Therefore, it is all the values are not there. Okay. So, therefore, f is not onto. Therefore, f is not onto. So, that's what is the conclusion now. F is neither 1 1 nor onto. So I hope that the clearly understood for the first part and the second part. First part is bijective, and second question is not a bijective. Why it is not a bijective? Here 1 plus x square, it is 2 and 2. When you are taking the minus 1 and when you are taking the plus 1, we will get the same answer, but 1 and minus 1s are not equal. Therefore, it is not a 1 1. Okay, now range of f is the value. What is the range of f? So take the value as 0, 0 you can take it as 1. So 1 is including and up to infinity, but it is not equals to r. Therefore, f is not a onto. If f is not a onto, then we can say that f is neither 1 1 or not onto. Okay, now I'll move to the question number 8 one. So question number 8. So what is the question number 8? Let A and B be sets. Show that f from A into B tends to B into A such that f of AB equals to BA is bijective function. Yes. So how can you prove this is what bijective or not? The same thing, we have to prove that let the two terms A1 and B1 and A2 B2 we can consider it belongs to what? A into B, right? Then, so what we can write? Then, so here f of A1 B1 is equals to f of A2 B2. No, the condition is given what? F of A comma B is equals to B comma A. So f of A1 B1 equals to B comma A. So now B1 A1 is equals to B2 A2. B2 A2. Why it is B1 A1? F of AB equals to B comma A. F of AB equals to B comma A is a given condition. So f of A1 B1 is B1 equals to A and B2 equals to A. Okay, clear? So now B1 equals to B2 and A1 equals to A2. So it means A1 and B1 is equals to A2 B2. Therefore it is 1 1 or not? Yes, if f is 1 1. F is 1 1. So A1 B1 is equals to A2 B2. Okay. Now next we have to prove it is what? Onto. So corresponding to every order pair of y comma x is belongs to B into A, there exists, what is it? There exists x comma y is belongs to A into B. Yes or no? So such that f of xy is equals to y comma x. So clearly we can say that f is onto. F is onto. Therefore f is bijective. So I hope that all of you clear this one. So here the condition is what is given. Show that f from A cross B tends to B cross A such that f of AB equals to BA is a bijective. So here 1 1 is already proved. F of AB equals to BA means A1 B1 and A2 B2, B1 A1 and B2 A2. So both are B1 equals to B2 and A1 equals to A2. So A1 B1 is equal to A2 B2. Therefore it is what? Function is 1 1 function. We can clearly say it is what? 1 1 function. Okay. So now we have to check whether it is a onto or not. So y comma x. Another one function we can take. Y comma x is belongs to what? B into B cross A. So there exists x comma y is belongs to A cross B. So both are same now. F of xy is equals to y comma x. Therefore f is what? Onto function. So therefore clearly we can say it is what? Bijective. So now next one is ninth one. So ninth one is here. Let f from n to n is defined by function f of n equals to n plus 1 divided by 2 if n is odd and n divided by 2 if n is even for all n belongs to n. So for all n belongs to n, so f of n equals to what is given? N plus 1 by 2 if n is odd, then n divided by 2 if n is even. No, n is even. Okay, so next one more thing is given, n is belongs to n, all the n is belongs to n. So here, what about f of 1? So n equals to 1 means 1 plus 1 divided by 2 equals to 1. And what about f of 2? F of 2 equals to 2 divided by 2 equals to what? 1. If n is 1, we will get this odd number, 1 by 2 it is 2, 2 divided by 2 is 1, and if it is even, it is 2 divided by 2 is what? 1. So now what we will say? F of 1 equals to 1 and f of 2 is equals to 1. So f of 1 is equals to f of 2. F of 1 is equals to f of 2, but 1 is not equals to 2. Therefore, what is this? F is not 1 function. Is that clear? So when you are taking n equals to 1, we will get 1 plus 1 divided by 2, it is 2 divided by 2 is what? 1, and 2 if you are taking here even number, 2 is even number, no? So n divided by 2, n divided by 2 is 2 divided by 2 equals to what? 1. So f of 1 equals to 1 and f of 2 equals to 1. So both the values are 1. It is not possible. These 1 and 2 are equal? No, x1 and x2 are equal. We have to prove that it's not equal. So it is not a 1 function. Now we have to check. It's onto. Why it is onto? Range of n. Range of f equals to n. It means codomain. Okay. So range of f equals to n. It's a codomain. For all x is belongs to n, for all x is belongs to n, such that 2x is belongs to n. So 2x is belongs to n. So f of 2x equals to what? X only we are getting. So f is onto. F is onto. Why it is onto? So all the values are satisfying here. All the values are satisfying. It means all the real numbers. So all the real numbers of this function is reversibly, it is what? Proof. Okay. So range of n is equals to n. So 2n is belongs to n now it is. So 2 of x equals what we are getting? X we are getting. F is onto, but not bijective. Why it is not bijective? It's not 1. It is not only that onto. So clearly, I hope that all of you clear this now. So n plus 1, it is not 1, but it is onto. Okay. So now the last question is the 10th one. Let a equals to r minus 3. 3 is not including and 1 is not including b. Consider the function f from a to b, defined by f of x equals to x minus 2 divided by x minus 3. Is f is 1 and onto. Justify your answer. So how can you justify it? So we have to follow the procedure now. So what is the procedure you have to follow? Yes. F of x equals to x minus 2 divided by x minus 3 is a given. Okay. Now x1 and x2 I am considering it is what belongs to a. It is a equals to what? A equals to r minus 3. Okay. Belongs to a is r minus 3. Okay. Now f of x1 equals to f of x2. F of x1 equals to f of x2. It means x1 minus 2 divided by x1 minus 3 equals to x2 minus 2 divided by x2 minus 3. Cross multiply it. x1 minus 2 into x2 minus 3 equals to x1 minus 3 into x2 minus 2. So now next multiply it. x1 into x2 is x1 x2 minus 3x1 minus 2x2, minus into minus is plus 6. Multiply. X1 into x1 is x2. Next minus 2x1 minus 3x2, minus into minus is plus 6. So now x1 and x2 get cancelled. Collect all the terms this side. This one get cancelled. Minus 3x1 and plus 2x1 equals to minus 3x2 and plus 2x2. So here it is minus x1 equals to minus x2, this get cancelled. X1 equals to x2. Clear? X1 equals to x2 we got. Here x1 equals to x2 means therefore function f is 1 1 or not. Yes, if it is what? X1 equals to x2 means it is what? 1 1. So these all are the simplification steps. I hope that all of you know this one, the cross multiplication and product and cancellation terms. Now we have to check whether it is a onto or not. So now let y is belongs to b. Let y is belongs to b and y is belongs to b and let f of x equals to what? Y. Y is belongs to b means all the elements of this is what same, it is belongs to b, and let f of x equals to y. It means the function is f from, what is the function? Function is f from a to b. So this is what belongs to y. Y equals to b. Then f of x equals to y. So f of x equals to y means x minus 2 divided by x minus 3 equals to what? Y. So now x minus 2 as it is you write down, then multiply it y into x minus 3. X minus 2 equals to xy minus 3y. Xy minus 3y. Then x is keep it as it is here. So bring this side. X minus xy equals to minus 3x plus 2. Then x I am taking outside, 1 minus y equals to minus 3x plus 2. Then x equals to 2 minus 3x divided by y minus 1. Okay, so it is what? Y minus 1. Is it belongs to A or not? Yes, it belongs to A. Why it is belongs to A? A is r minus 3. The function is f from a to b. F is function is f from a to b. So you are taking this is what? Y, this is what? Y, and this is belongs to y, this is what? Y belongs to b, and f of the function is you consider it as y. The next value what we are getting, that belongs to a. So what is the conclusion? Therefore it is 1 1. Onto. Therefore it is onto. So clear? So if it is onto, what we can say, it is a bijective or not? Yes, it is a what? Bijective. Okay. So now in the question number 11th one, it is options are given, but I am not saying these options, but we have to show that. Let function f from r to r, the function is what is that given? F of x equals to x to the power 4 is given. X to the power 4. So we have to check whether it is 1 1 or onto, or many 1 onto, or 1 1 but not onto, or neither 1 1 or nor onto. Okay, we can check now. So here the power is 4. Here is the power is 4. It means if you are taking x equals to 1, we are getting 1, and f is minus 1 also we are getting 1. So 1 is not equals to minus 1. It means x1 is not equals to x2. Clearly we can say x1 is not equals to x2. Therefore f is not 1 1 function. So already we know that in the x square, the first part we simplified the many problems here, x square and x square. Okay, so the same thing, it is x to the power of 4 means the term to the power of 4 is a even number. Okay, so now this is what? Not a 1 1 function. And also, so you can tell this x to the power of 4 is greater than or equals to 0 for all x is belongs to R. We can follow any one of the methods. So what about the range now? Range of f is equals to 0 to infinity. It does not belongs to R. Okay, so 0 to infinity does not belongs to R. So if you are taking 0 value, what you are getting? 0 we are getting. 1 1 1 we are getting. Then 2 to the power of 4 is 16 we are getting, but all the real numbers are not there. Therefore range of f is does not equals to codomain of f. codomain of f. Therefore f is not onto. F is not onto. So what is the conclusion? Therefore f is neither 1 nor onto. F is neither 1 nor onto. So clear now? So I hope that all of you clear this. Now last one is, very fastly I will explain to you. This is a very simple problem. F of x equals to 3x. So I have to check f of x equals to 3x, whether it is a 1 onto but not onto. So like this you have to check it. Now f of x1 equals to f of x2. This implies 3x1 equals to 3x2. 3 get cancelled. x1 equals to x2. Therefore what is that? F is 1 f is 1 all the problems are same. F of x is a condition, 3x is given, f of x1 equals to f of x2. If you want to prove 1 this should be equal. So now cancel these 3 and 3, x1 equals to x2, therefore it is what? 1. So now let y is belongs to R and function f of x equals to y. So 3x equals to y, x equals to y by 3. X equals to y by 3. Now f of x equals to y equals to 3x. So x equals to what now? Y divided by 3, right? So y divided by 3 is belongs to R. Belongs to R or not? So that it is, s belongs to R. F is onto or not? Yes, f is onto. Whatever the values you can take, that's all the values are pre-image is there. It means f of y divided by 3 is equals to y. F of 3, y divided by 3 is equals to what? Y, no? So therefore f is what? Onto. So here it is no? F of y by 3 equals to 3 into y by 3. So 3 get cancel equals to what? Y. So that is what? F is onto function. It means here it is 1 and onto. Conclusion is f is 1 and onto, are also called as it is what? Bijective. Okay, so thank you children. I will explain in the next video composition of functions and invertible functions. So please watch and like it and subscribe my channel for the more videos. Thank you children.